Welcome to my first video. I've been programming for almost 20 years and actually started my career as a game developer. After 2 years, I moved away from it, but it's been an itch for me over the last couple of years. Now I finally found the time to dive back in and build one. Recently, I've been posting a few videos about the game I'm working on. From now on, I want to go a bit deeper and explain the mechanics, software architecture and the ideas behind it in the series. The game is in full development. But to be clear, this is also a learning project for me because game development has evolved a lot over the years. In this part I'm going to explain the techniques behind how the terrain is generated and rendered. I'm not using Unity's terrain built-in system. Instead, I built my own terrain pipeline starting from pure data and ending with a rendered mesh in Unity. As you can see here, displayed by this wireframe. Every cross-section has a height point information. The first step is generating this height map. This is done using a custom smart terrain generator. It does not just create random noise, but combines multiple terrain types into a single landscape. This includes flatlands, rolling terrain, deserts, mountains, ridges, ravines, plateaus, and strategic base areas. As you can see here, pathway through the mountain. Each of these terrain features has its own parameters. For example, I can control how flat the flatlands are, or how aggressive the mountains become, how deep ravines go, or how subtle desert dunes should be. These parameters are exposed in Unity. Go to terrain on the right side, which allows me to tweak the terrain directly through the inspector. I can regenerate the terrain and immediately see the result, which makes iteration much faster. The generator also uses a combination of noise mask and heuristics to blend all these terrain types together into a single height map. After that, additional steps like smoothing, normalization and local flattening are applied to make the terrain more suitable for RTS gameplay. Once the height map is generated, I run an analysis step on top of it. This produces data such as slope, aspect, roughness, traversal, flags, semantic tags, and traversal cost. I will show you this right now. If we go into the debug menu, then we can do tdebug for debugging the terrain, which we have multiple modes. If I go to help, then I can show it. And then do tdebug mode, and then we can do like costs. So this is the terrain traversal cost. The redder it is, the more cost it is. So your units will move slowly. And we can have tags. So parts of the terrain have information tags with specific information on that terrain. But for now, I will change a setting for the, like say, the mountains, and the mountains is, so change the height to 5.8. So now they will become higher, because this is sometimes some flags work inverse. And it's now gonna re-render. This will take a little bit, so I will come back to you. And this data is not only used for rendering, as you can see, but also for gameplay systems like pathfinding, movement, and buildable areas, and block terrain. It's still rendering. After the analysis, a surface painting step determines which terrain layers should appear, where it is used. So you can see it's re-rendered. Now the mountains became way higher. Quite strange now, because the parameters are not set up correctly. It's just quite steep now, and a short shallow base. But this is also tunable through all those settings. And in the end, you have the global shaping, where you have like transition sharpness, macro variation, detail strength, erosion smoothness, etc., etc. And so on the Unity side, I use the mono behaviors to wire everything together. They act as the adapters between the Unity engine and the core systems. They handle the things like terrain generation, passing parameters from the inspector, building a mesh, assigning materials, and updating textures. And the actual terrain logic, like generation, analysis, and surface painting, lives outside the Unity specific code. This keeps the system modular and testable and easier to maintain. Because of this setup, I can adjust parameters directly into Unity and quickly iterate on the terrain without changing core logic. Mainly I will use this for testing, and I hope in the future there will be a little bit more of a map editor to apply other stuff, because there is also a support for patches and biomes, and this creates separate textures blend into the base textures, so you can not based only upon the heightmap which texture will be used, but also I can diversify the textures. But to tweak and edit that, you want something like a map editor, but that's for the future. And the shader itself is built around multiple terrain layers using texture arrays, and each layer has its own albedo and normal maps, along with settings like tiling, tinting, blend strength, etc., etc. So if we go back to Unity, and I will go to Unity, and I will go to layer bindings. You can see like layer 0, so this is the lowest layer. I can have up to 32 layers, something like that. But the more layers I make, the more channels I use, the heavier it becomes. So for now we have like 6 layers, and every layer can have its array of textures, and those will be blended together. But for every texture we will need normal textures or displacement textures, and if I have displacement textures I will create the normal maps based upon the displacement textures. So I do not have to use to create meshes for having some depth into my in my textures. Also you have settings like surface tiling to break up repetition on the terrains, blend strength, etc., etc. So you can tweak a lot of settings for creating the look of the terrain. For now I think it's somewhat shiny. That's something I have to fix. It's somewhat glossy, a little bit plasticky, I think. But those are things that we will figure out in the future how to fix. For now it's mainly the idea to get all the systems up and running, talking to each other and working together, and then tweaking and fine-tuning will be in a later stage. And to reduce the visible tiling, the shaders will use also macro variation, randomized sampling, and I think something that is called stochastic, a stochastic technique that helps to break up the repetition, which is especially important for large RTS maps, because if you have a lot of terrain and you see this repeating texture, this is not nice to see and it breaks immersion. So the normal maps are also blended per layer, adding surface detail without increasing geometry. Since this is an RTS, the performance is important, which is heavy work, and it's done early in that data pipeline. So the shader mainly focuses on efficient blending and rendering, and then preparing the data. This is also cached upon boot, so after if you do not change any parameter, the data is getting loaded from disk, which saves a lot of loading time, because rendering and tweaking and building the maps is quite heavy at this moment. So the terrain system is not just only visual, it's tightly connected to the gameplay, navigation and world logic. I just show you some information about the terrain information. There's a third layer, and this is the navigational grid that's based upon top of the data layer. This is a more fine-grained, grid. So if we go back to terrain debug and I go to mode wireframe, this is the terrain heightmap wireframe, and if we go into the nav debugging and we put it on, you will see that the navigation terrain is twice as small, so that we have a more fine-grained pathfinding, which could be heavy in the end, but for now not every unit is using A star for navigating the terrain. If we select a group, there will be a group pathfinding, so we only figure it out once for the group, and this will be saving a lot of calculations when we go full scale. Every unit has its autonomic behavior within its local scope. So also this movement consists of 3 layers. You move a group or a single unit, which does a top layer, a global pathfinding to its target, and then it has its autonomy to move along that path to get to its target based upon the terrain information that it is analyzing. It's very weak at the moment, because if I make it more autonomous, sometimes they will drift off because they think they know it better than the algorithm itself. And then there is a group orchestrator that will be sending specific information to that group for the formations and to have its final position. So every unit will have a slot within the group, and they will move to its final stage. So there's a global movement, and then there will be a final movement to get positions in the right spot. So you can see it here. They formed in a nice, neat line with the same heading. So this is the main reason I built the terrain pipeline. So instead of using the Unity terrain, this gives me full control over how the terrain looks and how the games understand it, and how I can interact with all those systems. Yeah, it's not AAA, probably won't be ever, but it's working quite nicely. Some extra information in the left top corner. You will see the point for my mouse. You will see the extra information, the tags, the flags, the cost, how rough it is, which class it has, slope gradients and such, coordinates. Yeah, so this is all the information for now I have about building the system. Maybe I can show you a bit more into Unity about the terrain. So we had the terrain generation stuff. We have the layers, and I talked roughly about having biomes. I've not set this up yet. It does work. You can have the biomes, and this is just a region you can add. I think I probably should stop the game. Yeah, I should stop the game. So you can add a biome or a patch, and they have a location and a layer ID. And if you have it, give it a layer ID, like 6 is snow, but you will locate it somewhere below in a ravine, and you give it layer ID 6, it will take up the textures used in layer 6. And then you can create a patch or a biome based upon that layer. So you can blend in different textures on different layers, so you have more diverse texture usage. But we need to add a lot of decals, etc., in the future. So for now, it's nice to have, but not really used at the moment, because it's not that interesting for now.